Hello there everyone, my name is Crazy Caleb and welcome to Yellow Buttoned. This is the way the module looks. It's going to be a square button that is going to be yellow. That's going to be the main way that you're going to determine this. And the big difference between the other buttons in the series is the fact that there's going to be a file name in the top screen here, and there's going to be a file size on the button itself. And in this case, we happen to get, ironically, 404, which means error. But in this case, it is a 404 megabytes. It will always be megabyte in the actual name. In this case, in the file name, if it happens to go above 1,000, for example, in one of the conditions, it will just be 1,000 megabytes. It won't be like a gig or something like that. That's not the way that works. It will always be in megabytes, and cases where the file size is doesn't mention megabytes will be always considered in megabytes, just to make sure. So, what's going to be happening here is we're going to have two different bytes that we're going to need to be paying attention to, and these represent the topmost represents the most significant bit. In this case. If you were to write this out in a number, for example, or in binary, the most significant bit would be the one that is in the greatest. So in this case, this one, if this happened to be a 1, for example, and this happened to be a 0, the 1 would be the most significant bit because it's the furthest left, representing the greatest power in that number, and the 0 would be the least significant bit because it is the last digit in that case, and it represents the lowest bit. So that's going to be the way that this works. And what's going to be happening here is that we're going to go through each of these conditions. And what's going to happen here is between each of the positions in the bytes, we're going to be applying the AND operator. The AND operator essentially means that both have to be true to return as a 1. So that's going to be the way that this works. Now, a little bit of terminology needs to be cleared up for one specific rule. Is that these individual cells here represent different statements. These are not what they consider as true conditions. So for example, if say the file size was even, but the file size was not greater than 500 megabytes, this would not count as a true condition. A condition works when both of them happen to be true, and in this case, both would happen to be, this would be a true condition. That would be the way that this works. Conditions are if both in the exact same position are indeed true, not the individual cells themselves. So what we're going to do here is we're going to generate a binary number from these two bits based off of the positions, and we're going to be applying the AND operator as I mentioned beforehand. And what these are going to give us is this is going to give us a series of rules that we're going to be following down here. But for right now, let's see what we can do here. And the way that I'd like to do this is I like to go through this position by position, just make it easier on myself. No need to highlight anything that doesn't actually need to happen. And if we happen to have the left condition being false, we can already skip down to the next position, because if at least one returns false, we know that it's going to result in a 0. So, first rule, the file size is greater than 50 megabytes. This is indeed true. So let's check the second condition. The file is an image file. Now, there are a couple little bits of extensions here. The extensions are going to be in the last bit. The name itself, the name is going to be this first little bit, and the extension is going to be the last little bit after separated by the dot. Note that if you happen to get a case where the file name contains an A, or for example an X, and you happen to have the case of docx as a text document, this does not count because of the fact that the file name does not include an X, for example, but rather it's the extension that has an X. It's not the file name. It's the extension. So in this case, if the name did not have an X, but the extension did, this rule would not apply. Just need to make sure that that is very clear. Extension is different from the actual name. So the file is an image file. Let's check. A WMV. Now there is the possibility of there actually being neither a text text extension or an image extension, and in this case, it happens to be both of these because it's neither a text extension or an image extension, so it's neither of those two. WMV, I'm not sure what that is off the top of my head, but as you can see here, these are the only ones that count as text and image extensions, respectively. This fits into neither category, so this rule is not going to be true. This first position is going to be marked with a 0 here. Next up, file is a text document. We already determined beforehand that this was neither of these, and these are going to be the only two that are considered in these rules. So we can already tell that this one is a 0 based off of the AND operator. If this returns false, it's already going to be returning as false. The file name contains an A. Sepsis does not have an A present in it, so therefore this is going to return as 0. The file size is less than 200. In this case, it is greater than 200, it is 404, so this is going to be now marked as a 0. file size is less than 1 megabyte. Obviously, it is indeed less than 1. It is indeed greater than 1 megabyte. So this is going to return as a 0. The file size is greater than 1,000 megabytes. Not true. It is less than 1,000 megabytes, so that's going to return as a 0. And true condition is greater than or equal to 1. We don't know that quite yet in this case because we have to go through all these conditions. This will be the last one that you apply. And the second byte of this will always return true if there happens to be the case where you happen to have at least one condition true. This is the only case that is going to be preventing you from the AND operator applying here. The file size is even, that is true, and the file size is greater than 500 megabytes, not true. So therefore, this one is going to return as a 0 in the last position, and since no true conditions were able to apply here, this is simply going to return as a not true because it needs to be greater than or equal to 1. So therefore, all of the numbers that we get are going to be equal to 0. Now, we're going to place the binary digits obtained from the previous step above the table below, and each one indicates that the condition in the tables are true and vice versa. So all of them happen to return false. And now what's going to happen here is that we need to execute all of the bits from left to right to solve. And all of these conditions, as you can see down here at this bottom bit, represent the 8 individual bits that we have to go through here from left to right. So all of the following conditions refer to the last 2 digits of the timer when you tap the button. That's where this thing gets a little bit interesting. So if any of these were to return as a 1, for example, if we were to do the third position, what would happen here is you would have to apply this rule, the modulo 2 is equal to 0. So that would mean that this has to return as true. So effectively, the way that the modulo works is if you were to, for example, say we had the number 53, for example, if we were to modulo it by 2, which is essentially subtracting by said number until you get below the number or reach 0, which in this case we're going to reach 1. And this is not going to be returning as true for this. We need it to be an even number in order for it to actually reach the 0, in order for that to be returning as true. But in this case, we're not going to be doing this. So what happens when we have to do zeros? Well, we're simply not going to be applying the case of even for our first press. So we need to press the button when it is an odd second, like so. Now we're going to do the next one, odd. This returned as false. We're going to be pressing it on even. We're just going to be doing the exact opposite of what it wants you to do. Next up, modulo 2 equals 0. This returned as a 0, so we want to press it on an odd digit. This is just another way of writing, hey, even or odd in this case. So next up, we need to press this when it is not modulo 2 is equal to 1. So this is going to be an even digit. Okay? Next up, modulo 3 equals 0. We don't want to do this on a multiple of 3. So for example, we can do it at a 55 would work. That's good. And now, the size of the file is a bit of a weird rule, and it's actually quite easy to overcome. So if this happens to return as true, which it's very rare, keep in mind, because it has to be over 1,000 megabytes and it has to be odd. But if this happens to be returning as true, what's going to happen here is you're going to tap the button when the last 2 digits of the timer is the file size in megabytes, modulo it by 60. So, in this case, all we simply need to do is because of the fact that we're going to avoid it, all we're simply going to do is we're simply going to avoid the last digit of the actual timer being 4. So we can click it right now. Next up, we're going to be avoiding even, so let's do odd. And next up, we're going to be avoiding it being greater than 50, which in this case is indeed a perfect time to do it. And just like that is a solved module. So let's go into one more example. This module itself, fairly simple to do, fairly simple rules to understand, but it's obviously going to be a bit tricky to, it's a bit tricky at first with some of the terminology, absolutely. There is, in my opinion, there is some bits lacking in this manual for clarification, especially with regards to conditions, and I mean the statements do technically cover it here, but conditions might be a bit misleading. For example, if you were to have the file size being greater than 50, you might think that this might count as a condition. However, it does not. It's only one statement. The condition applies when both are good, when both are true. And that's how the true conditions comes into play here. So let's take a look at one more example. Let's see if we can maybe get some other presses here. And we actually might here. So we've got quaint in the name, and we've got the extension of ISO. This does not apply to either of these. Again, trust me, there are a lot of extensions that actually don't apply to either of these, but but these guys absolutely can pop up in the module here. So let's take a look and let's go through these rules here. So we already know one thing is that the file is not an image file, so we can already skip these two rules immediately. In fact, we can skip any of them with these text documents here, or image files. So we can already get through those. Now, next up, the file's name contains an A, and the file size is greater than 200. That is indeed true. Quaint does indeed have an A, and the file size is 720 megabytes. Therefore, this returns as true. So already we have 0, 0, 1. Next up, the file size is less than 200. No, it is not. And as you can see, a lot of rules, they kind of contradict each other. In this case, the file size is greater than 200. Therefore, this rule already is not going to be true. It's already just not going to work. But you can't have both of them at the exact same time. So that already is going to be 0. We've already determined that the fifth position was 0 just based off of the text documents. It is not a text document. Next up, the file size is greater than 1,000 megabytes. Not true. That's going to be 0. The true conditions is greater than or equal to 1. In this case, that is indeed true, because we've already had one case that applies here. In this case, that returned as a 1. This, therefore, means it's a true condition, and the second byte is always, so that means it's going to be returning as a 1. And finally, the file size is even, and the file size is greater than 500 megabytes. This is indeed also true here, because of the fact that the file size ends in a 0, it's even, and the file size is greater than 500, it is 720, so therefore, this is going to be our final string of digits here. And now, generally what I like to do is I like to mark the positions in green. I guess that would be returning as true here, which in this case will be these guys over here. So now, what we're going to do here is we're going to click when it is not even, when it is not odd, when the modulo 2 is equal to 0, which is just another way of writing even in this case. Okay, not odd, which is even again. Not a multiple of 3, so 35. The size of the file does not have the last digit of 0, which in this case we can do this right here. Okay, the last digit being even. And now we have to wait a bit, because we have to wait for it to the last two digits to be greater than 50. So we can do 59, for example. So we're going to have to wait 17 seconds, but that's all there really is to this module. It's fairly simple conditions to do. It is similar to the module called bitwise operators, for those of you who are familiar with that older module. There is just a couple different changes to it that you need to be aware of, and you will be good to go. So let's hit it on 59, and signing off, and just like that, is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.